Hi, and welcome back to another episode of Hunting Liquid Damage. Now, this one's going to be a little bit more difficult than the ones that we usually work on. This machine over here has been to another store, so the person said they did not spill anything on it. They said afterwards they gave it to a store. After attempted repair, that store then said that they should come here, which means that they brought it to somebody after saying they did not spill something. The other place found the spill and then cleaned it off, and then they sent it here so that I could try to fix it without knowing where the original spill, that according to the note they did not spill on it, is. And that's what makes this just a little bit difficult. But we're going to find it, and I'm going to find it with your help. So let's just go over this board and see if we can find out where the spill is. Now, it's not turning on, but it does have a green light, and this is missing PM sleep S4L, which, as I talk about, is the most miserable signal to be missing because it can be almost anything. That amounts to what I like to call an open-ended problem. It can be an RTC circuit failure, it can be some type of a BIOS issue. Duke has said that a bad BIOS is not going to do that it'll move up and down, but I haven't had that experience. And Duke is usually right about these things, so I don't understand why I don't have that experience. Maybe I'm just being an idiot. So we're just going to search up and down this board. Pretty excited. On Monday, the digital microscope arrives from the company that wanted me to try it out. We'll see if that winds up being a good thing. It's dynolite.us. You can find their stuff at dynolite.us. So we'll see if this is a good microscope, a bad microscope, something usable, something not usable. This is interesting, because this is the first time a company is actually sending me a product and saying, you can keep it, just use it, maybe put it in a video, and not asking for a good review, not asking for a bad review, not asking me to send it back. We'll see. I mean, I don't need another microscope, but I do have the student station over there. And when the student station is in use and when I'm here, the other guy who works here can't do his job. So having another one, it'll help towards building a third station. But this all, again, it depends on whether or not the thing that they send is actually usable. Okay, we go through. I don't see any liquid yet. But keep in mind, it's going to be hiding because this was cleaned. Alright, so we're going to keep moving along here and see if we can find it. This is going to be difficult. We're getting close to the end here. We're getting close to the end and... oh? You don't have to be surrounded in green to get me. I see you. You're right there. I found you. PP3V3SO. Oh, that's no good. It's no good when that rail has some issue. Oh, man. Okay, so that means that under that chip there may be a burned connection. And if that's burned, then the PP3V3 sus looks like it's had a burn, and the same area on these boards around U1950 that always gets burned when there's liquid. See how that left pin is more green than the pins on the right? The one all the way on the left? Yeah. Alright, so let's see what we can do here. Let's get... we found our liquid damage. Beautiful. Absolutely beautiful. So now what we got to do is just have to take off this stuff that is liquid damaged, kick on the air filter and fume extractor and all that good stuff that makes lots of noise, that makes recording a nightmare. Now, what's interesting and what makes me wonder if this will actually solve my problem is that PM Sleep S4L is missing, right? PM Sleep S4L is what gets me into an S4 state. Right. and S3 state on the older boards. This here is designed to get SO going. So I'm kind of wondering, I mean, if I don't even have PM sleep S4L, is this going to do me any good? But I can't lose by taking off the stuff that is obviously corroded, so we're just going to start here and see what happens. So let's heat. These tweezers are just, man. These tweezers look like dog shit. Okay. We're just about melted. These boards are very, very good at absorbing and then dissipating heat. Does that look nice? Does that look nice? Now this trace and pad over here that look really bad, that's for PP3V42. And if that looks really, really bad, that means that there was ripple on PP3V42. Ripple on PP3V42 is going to mean that other things that are powered off PP3V42 may have also been damaged, which is something that we're going to have to keep in mind here. So anytime you see points that look like this, I want you to think of it as if lightning struck that point, not thunder. If lightning struck this point right over here. You understand? And then look at it like, what else was on that line? What else could have been struck by that lightning? And somebody walks in, so we will be back in a moment. And back to work. Now that my board has made itself cold again, so we have to start from, well, scratch. There. Alright, so these boards are hard to heat up. Alright, so I have to scratch this off. This is burned. There's nothing left over here at all, so I'm just going to have to run a direct wire. So let's get that started now. I'm going to take myself a little piece of battery wire here. So this is pretty much the wire that came out of a 15-inch MacBook Pro battery. I just cut it up into a bunch of little strands. I open it up, and now I have a wire that I can use to run a jumper. It's going to go something like this. So it has to reach out to here. Alright, so from here to there, here, bam. Now we get rid of the excess, and another person walked in. Back to work. I've given up on finding a weekend receptionist. I've been trying for 4 years, and it just never works. Never works out. I just lowered the hours on the weekend from 6 or 8 hours to 4 hours, and just me, myself, and I. It's a lot of work to teach somebody all the little intricacies of what to say yes to, what to say no to, what to tell people. For somebody who's going to work for 8 hours a week. And now the phone rings. Aye, aye, aye. And back to work. So, let's just even out what we have here. And get the hot air back on. So you have to put a resistor here, a capacitor there. And we're just going to go over these areas which don't look very nice. And now what I'm going to do is I'm going to take my nozzle off of the hot air because this, with the air conditioner on, the room is kind of warm. Here, tweezer. Here, tweezers. I have my tweezers right in front of me. Where'd they go? Where'd they go? Oh, my tweezers are always running away from me. Always running away from me. Okay. So what we're... take this off. Once you take that off, you get a lot more heat. Just turn the air up. And somebody walked in. I'm not going to get shit done. Let's try again. He wants me to... Oh, Jesus Christ. Ah. The issue that I find is that the people who are smart enough to not have to walk back and forth constantly to ask me questions are the people who want a full-time job. So every time I've gone for like a weekend person, it pretty much just winds up being like a game of telephone where they just walk back to the office and interrupt me anyway. But I don't know, it would be nice if I could get a smart person that were willing to work part-time 8 hours. But again, that just doesn't... In my experience, that has not been the case. So now we go up here. Where was I? Okay, I have to remove this thing. Over here. And I'm going to take this cap. And this thing and that. Alright, so... we've got a lot of preheating going on here. Yeah, I don't have the nozzle on it. Still didn't come off very cleanly because the board is cold since the office is kind of cold with the air conditioner. And the board keeps cooling itself down every time I get up, so there's that as well. I also have to put in that resistor that I forgot about up top. Okay, let's get rid of all the lead-free solder here. Scrape all that stuff away. And okay. Capacitor. Yoink. This capacitor can go on a little bit sideways. You don't have much of a choice. And we're going to flow that into place, so don't worry about the fact that it doesn't look perfect. That's all going to get nicely flown into place. Flew or flown? Now, we get the capacitor, and once the capacitor is flown into place, or flew into place, or flows into place, whatever the hell you're supposed to say, that chip itself should also have flowed its way nicely. Just gonna let surface tension do the rest. Okay. Now notice how I'm spinning the Q-tip. The reason I'm spinning the Q-tip is that the fibers of the Q-tip don't get stuck on the board. They will get stuck on the board if you go back and forth. Now you may wonder, why don't I just get proper cleaning utensils that don't leave fibers at all? And if you looked at what the price of those things cost, they're pretty much Q-tips, but they rape you by charging you 10 times what a Q-tip costs. So fuck that. I'd rather just use the Q-tip, but spin it around like this. This is one of those areas where using your brain will save you some money. And I am cheap, and I like using my brain. Now, remember my considerations that I talked about? We have to consider that PP3V42 had a spike. That's why that looked nasty. PP3V3SO had a spike, so hopefully the SSD is still good. Since almost every single one of these boards are PP3V3SO at a spike, the SSD is fucked. And let's see, do we have any change in anything? Do we have a fan that spins? Hey, check it out, it spins. So it's interesting how circuitry that affects PM, sleep, I mean, the circuitry that affects the SO rails is somehow managing to affect the PM sleep S4L signal. I think that's pretty interesting. So I guess we should just go over on the schematic a little bit of what was nasty there, and so that you have an idea of what was going on. So let's just move this out of the way. So what I do, one of the things I do with this microscope setup, I don't have the articulating stand, but what I do is I have a locked thingy at this height, so it's stuck at this height, and what I do is I don't tighten the other one, so I can just do this, so I can move it kind of wherever I want without having to worry about things. So it's a nice combination between the articulating one moving, but also it being sturdy and not jumping up and down constantly. Anyway, let's open up a schematic here and see what we have. So I'm looking for 820.3476. All I have is 820.3536, which is close enough. Close enough for good. Good enough for rock and roll, as they would say in the studio business. Which is why you probably... That's one of the... it's sayings like that that make it really obvious why you wouldn't want a studio technician repairing... A studio technician, like, repairing medical equipment. I mean, don't get me wrong, they do good work. It's just sayings like that. All right, so we had a lot of corrosion right around here. So U1950's job, just make sure on the screen we are. U1950's job is if all system power good are present and CPU VR P good is present, which is going to come from CPU VR enable. If all system power good is there and that's there, create PM SOP good. If PM SOP good and SMC delayed power good are present, we get system power OK, which comes to PM PCH sys power OK, which goes into the system power management section of the PCH. And if you've watched some of my older videos, you know that the idea here is when you have the inputs on the left for system power management, you get the outs on the right. Now, the reason I'm a little confused as to how anything that I did actually fixed anything, look at this. For this logic gate to work, A and B have to be present in order for you to get Y, right? Right? Okay, if you don't get that, you can just Google this little thing over here and it'll show you that. This is the name of the chip and it'll show you that the way this gate works, if you have A and B, then you get Y in output. Now, one of these, B, is a signal that's going to be pulled up by R1950, which comes from an SO rail. So if I'm not even getting the enables required to be in an S4 state, then how would I be in an SO state? Which is a really interesting thing. Next question here. Let's go over to the other piece that was a little bit burned. Was U1420. Let's see what this does. Okay, U1420, sleep SO isolation. These are both required for SO. So, I don't know. Maybe Duke is right. Maybe there is pulsing on S4, and that was pulsing, but since that logic gate was dead and not putting out PCH power, okay, PM sleep S4L did not decide to stay on. But I measured it. What I did is I had my multimeter, I had them right there, and I have the MagSafe with my pinky. And what I usually do is I try measuring PM sleep S4L. What I do is I have it measuring, and then I let go my pinky, the MagSafe plugs in, and I don't see a spike. So I don't get it. But I fixed it. So as always, again, if your brain, wherever your brain fails, hopefully your eyes succeed. Here it was a little bit more difficult because, again, it was hidden. It was cleaned up before I got to see anything, but well, we figured it out. So as always, I hope you learned something. And I hope that guy's SSD works because, again, Ripple on PP3v3SO, that is, you never want 12 volts going to your SSD. That's just, I hope his SSD is good.